Here, we'll introduce a few anomalies that can occur in LP problems. They are alternate or multiple optimal solutions, redundant constraints, unbounded solutions, and infeasibility. Let's take a look one at a time. The situation with alternate or multiple optimal solutions has been alluded to in a previous video when we introduced graphical approach to solving LP model. In our Blue Ridge example, what if the aqua sparse unit profit is 450, everything else being the same? Because that the slope of the boundary line of labor constraint is -3/2, if aqua sparse unit profit is 450, then the slope of level curve is also -3/2. The level curve or isoprofit curve will be parallel to labor boundary line. As a result, the entire line segment between 122.78 and 174.0 will be able to yield the highest possible profit of $78,300. Alternatively, if we go with the corner approach, we can easily find that the two corners 122.78 and 174.0 both yield the highest profit of $78,300. So everything in between will do the same. This is the situation we call alternate or multiple optimal solutions. A second anomaly we introduce is redundant constraint. Let's say in our Blue Ridge example, it turns out that there are 220 pumps, everything else being the same. The resulting feasible region will be looking like the shaded area on this graph. What stands out here is that the feasible region has nothing to do with the pump constraint boundary line. That is to say, with or without the pump constraint, the optimal solution will be just the same. Being able to identify redundant constraints is very helpful for us to solve LP problems. As briefly mentioned before, the most popular method used to find optimal solution to LP problem is simplex method. One or more redundant constraints may lead to a situation called degeneracy of LP, when simplex method cannot work properly to find the real optimal solution. Since we don't go deep into simplex method in this course, we'll simply provide such a brief introduction, and in sensitivity analysis, we'll see degeneracy come up again. Unbounded solution is the situation in which the feasible region is unbounded, going all the way to infinity. In the maximization problem, unbounded feasible region will result in unbounded solution. In reality, it probably does not make practical sense. So usually, when unbounded solution occurs, it is more than likely that one or more constraints are missing. Lastly, let's look at infeasibility. Infeasibility is the situation where feasible region is an empty set, or there's nothing feasible at all. In the example we see here in this graph, the sum of x1 and x2 must be 150 and 200 simultaneously. It is simply impossible. Infeasibility occurs when there are conflicts like that. It usually reminds us of double-checking our LP model, making sure that there's no error in our model itself.